Hi, welcome to this ANOVA tutorial. I hope this guide helps you throughout your study. If you have questions at the end of the video, don't hesitate to look for me. As far as we've seen during the course, we were comparing a single sample mean with a theoretical value or the mean between two groups. The analysis of variance then comes up as a very effective tool for hypothesis testing, as it will allow us to compare the results from more than two groups or collection of experimental situations within the same framework, thus simplifying our statistical procedures if we were, for example, running multiple T or Z tests. Also, it is important to know that there are different types of ANOVA tests. In this case, we'll refer to the simplest ANOVA problem, that is, single classification, or one-way ANOVA. It involves the analysis either of data sampled from more than two numerical populations or of data from experiments in which more than two treatments have been used. Common situations where we would intend to use ANOVA are an experiment to study the effects of three different types of music on different groups from the same population, an experiment to study the effects of stimuli such as placebos, nocebos, and no stimuli over samples from the same population, an experiment to investigate whether different concentrations of sugar affect the reaction time of our subjects of study. Notice that in our first example, the factor of interest is the music type, and there are three levels of the factor. In the second situation, the factor is the stimuli, with two levels of the factor, or three, if a control situation, as the no stimuli situation, is added. In both 1 and 2, the factor is qualitative in nature, and the levels correspond to possible categories of the factor. And in 3, the factor is quantitative, so the levels identify different settings of the same factor, as the amount of sugar in this case. Now, let's look at our first example. The table describes an experiment in which different music genres were used as a stimuli to measure levels of relaxation. The individual scores appear in three different categories or classifications: rock, jazz, and classical music. Samples of three measures per category were taken. The table presents the results of a one-way ANOVA test. Single-factor ANOVA focuses on a comparison of more than two population or treatment means. The relevant hypotheses are as follows. Notice that if you have three categories, H0 will be true only if all three mu's are identical. The research hypothesis will be true only if one of the population means is different from the others. Also, some of the requirements when working with ANOVA are the following. As you can see from our example, we are just categorizing our populations by music genre. Another important assumption is that every population we are studying will have the same variance. Of course, we know that this won't happen in real life. Anyway, let's just keep it as an assumption for now. Another requirement is that samples should be independent of each other, meaning that the result of an individual observation won't affect the next one. As I mentioned before, one of the main objectives of ANOVA is the use of samples from three or more different populations to test the claim that all populations have the same mean. If the null hypothesis is accepted, then music genres have nothing to do with relaxation. If this is the case, we will see how the means not differ too much from one another. Now, to get the test statistic for single-factor ANOVA, we will need to study the F distribution. This one is very similar to a chi-square distribution, where the F distribution is not symmetric. Also, the values of the F distribution cannot be negative, and the exact shape depends on two different degrees of freedom, a numerator and a denominator. Now, the test procedure is based on comparing differences between samples variations. As mentioned before, we'll be studying variances between groups and variances within the groups. For our example, it will be defined as follows. we will be comparing the results between groups and also the individual scores within the groups. Let's start working on problem solving with ANOVA. The first step is, as with other hypothesis tests, the statement of our related null and research hypothesis. We'll be using a level of significance of 0.05. The second step is the procedure to get our F-critical. As we have seen on a previous slide, the shape and values for the F-critical depend on a numerator and a denominator. So, to find the degrees of freedom between groups, we'll use this formula, where K is the number of categories from our experiment, and the degrees of freedom within groups is equal to N minus K, where N is the total number of scores and you'll subtract the number of categories we have. With this information, now we can calculate from the table our F-critical. Along the top, you will find the degrees of freedom for the numerator, meaning the degrees of freedom between, and on the side, the values for the denominator, meaning the degrees of freedom within. With this information, use it as you have already learned from previous hypothesis tests. Find the level of significance you are running the test at, and then cross the column and the row corresponding to the values you got. With a value for F-critical, we are ready to go to the third step. First, calculate the mean for each condition. To do this, you will add the individual scores from each music genre and divide it by 3. Now, you have an X bar for each category. Then, calculate the grand mean by adding the mean from each condition and dividing it by the number of categories, in this case 3. Next, we will need to calculate the sum of squares. This is done by subtracting the grand mean to each of the individual scores, square the result, and add all your resulting values. To get the sum of squares within, we will do pretty much the same, but with the mean for each condition on its corresponding category. Finally, we will calculate the sum of squares between with the following expression. With this, we are getting close to the end of the procedure, so please pay attention to this. Remember that one of the main purposes of ANOVA is to measure the variability between different categories. So, everything we've been doing until now is to get a measure for the variance between and within. For this, we'll be using the degrees of freedom we have already calculated from step 2. Now, we've got all the relevant information we need to get our test statistic, the final step in ANOVA. Now we can compare F-critical and our test statistic to launch a conclusion. If we look at the distribution, we'll notice that F-critical is greater than our test statistic, meaning that this one is not inside our rejection area. Therefore, our null hypothesis is accepted. With this, our ANOVA test is finished. Please, if you have questions, let me know. Write me an email or comment the video with your doubts. I hope this video helps you with your studying. Thank you for watching.